All right, good morning, everybody. We're starting Chapter 2 of Unit 2. Let's just go ahead and take a look at this just to review. We've already completed Unit 1, took our test on that. And here we are, starting Unit number 2. We're talking about atoms and elements. You have already tested on 2.1, parts of the atom. So now we're going to move on over to 2.2, the arrangement of electrons in the atom. So let's go ahead and click on that. And let's go ahead. I'm going to cover this, engage with you guys in class. But let's go ahead and just jump into Explore number 1. You can see there's 4 explorers. So 4 days, 1 for each explorer. And let's draw our lines, okay? Today's date is the 18th. So today is Wednesday, 10/18. 2023. We'll give ourselves enough margin space to write notes to ourselves. And the essential question, we'll go ahead and use the essential question right here off of this page, right? This is going to be our essential question. So go ahead and write that down. What arrangement of electrons in an atom did Niels Bohr propose? What arrangement of atoms did Niels Bohr, we'll just go all the way across here, propose? Question mark. And we're just going to draw my line to cover all of that. Okay. Niels Bohr was a scientist, but he was not the only person who came up with an idea on electrons and their arrangement around an atom. There were plenty of people before him. If we take a look at our text here, it seems like it starts with a gentleman named Rutherford. Okay, so we've got Rutherford. We also have J.J. Thomson mentioned here. So we've got Rutherford and Thomson. And a quick scan here. Is there anybody else that they're going to mention here? And then, of course, they're going to mention Niels Bohr a little bit further down here. Bohr joins Rutherford's lab in 1912. Okay, so we got a couple different players here. What did they say? Roman numeral 1. At the turn of the 20th century, understanding the structure of the atom was one of the most sought-after goals in physics. As far back as 1897, J.J. Thomson discovered the electron and proposed his plum pudding model of the atom. Okay, so maybe we can write down the history of models. And what we have is we initially had J.J. Thomson, 1897. J.J. Thomson in 1897. He had this model called the plum pudding model of the atom. Okay, we'll go and put that down there. The plum pudding model. I think in essence, this idea of a plum pudding was this idea that you could have a container, let's just say, a bowl, of pudding. There's your pudding, And you maybe had these kinds of plums or raisins kind of located throughout it. And so his idea was that this was an atom with electrons dispersed throughout. Okay. Now, as time went on, this model gave way to a different model. And this brings us to Ernest Rutherford. All right, so let's go ahead and introduce this new. A few years later, we have this gentleman named Ernest Rutherford. He challenged Thomson's model, and Rutherford concluded the atom must have a nucleus. So Rutherford said the atom must have a nucleus. Okay, that was what his thought was on that. Rutherford proposed that an atom's mass is concentrated at its center. Now here's what's interesting. The mass is concentrated at the center. Protons and neutrons had not yet been discovered, so Rutherford could not tell what the nucleus of an atom is made of. So he just knew that there was something in the middle. Rutherford was unable to determine the arrangement of electrons in the atom. Okay, was unable to determine the arrangement of the electrons in an atom. He suggested that the electrons moved in orbits around the nucleus, but had no evidence. So he was on the right track, but a lot of people disagree. This was poorly received by physicists at the time. So let's write down some points here. Rutherford said that there was a nucleus, and this would be a nucleus. And he suggested somehow, some way, that electrons moved around. They orbited. Right? Electrons orbit. And that was his idea. He didn't know about protons, didn't know about neutrons, didn't have any evidence to support this idea of electrons orbiting. This was all just hypothetical. This was hypothetical. It was a hypothesis, right? Now, if we continue to move through here, in 1912, we have Niels Bohr. Okay, and Niels Bohr is the first person who really kind of takes these models and moves us forward. Okay, so Niels Bohr, 1912. I believe he was Dutch or something like that. Niels Bohr. Bohr's careful research led him to propose a model of electron orbits that satisfied both experimental evidence and the laws of physics. Okay, so he proposed that electrons orbit a nucleus, right? And you'll probably want to watch this video over here. And we'll probably want to come back to this to fill out this model, because your text now is going to kind of divert us a little bit and talk about light-emitting atoms. And somehow this is going to be related to these models. So let's go ahead and put down, if this was A, okay, then this will be B over here. Light-emitting atoms. When Niels Bohr began his work, several observations of atomic behavior had not yet been explained. One set of observations concerned the way that atoms emit light. Right? So here's an interesting thing. Question. Why do atoms emit light? Scientists had observed that different elements emit different wavelengths of light. Now, these wavelengths are seen as colors. Neon gas, for example, emits red light when an electric current passes through it. Xenon gas produces blue light. The colors, I'm right over here, the colors emitted by elements are called emission spectra, and each element has a specific emission spectrum. So if you have a tube, and you have, say, hydrogen gas in here, or you could say neon gas, neon, which is element N, it's a gas, right? So you have these neon particles in here, and if you were to run some electricity, you have a positive end and you have a negative end. If you were to run electricity through here, then what happens is you're going to get a light that is emitted. And let's just see if I can pick a slightly different color here just to kind of help us out here. We'll just pick this color here. What happens is you get this light that is emitted. And the question was, why? Why is it that these atoms, why do atoms produce light? Question mark, right? Each element also absorbs wavelengths. So not only do they emit, okay, this was what we called an emission spectra, but they also, let's put a little star here, atoms also absorb wavelengths of light. And we call this the absorption spectrum. Okay. The emission and absorption spectra, let's go over here. The emission and absorption spectra of hydrogen were of great interest to scientists at the time that Bohr began to work at Rutherford's lab. All right, so we just talked about nitrogen, but historically, people were interested in the simplest element, that being hydrogen. And how does this all work, right? Okay, so let's see here and clear screen, and let's just keep on moving here. Bohr used spectroscopic observations of hydrogen and other pieces of experimental evidence to guide his research. He discovered that specific patterns of light emitted and absorbed by different elements is connected to the arrangement of electrons in their atoms. Okay. So let's go ahead and just draw this out here, okay? So Bohr's model was something like this. You have the nucleus, right? You have your nucleus. And he suggested that you had these electrons that were orbiting. And when you had an electron that moved up to the next level, it absorbs energy as it moves to a higher level. And when should it come back down to its ground state, it's going to, light is emitted. Light is emitted when it returns to a ground state. This is the energy that was originally absorbed. The energy originally absorbed is released. Okay, so how did that electron jump to begin with? Well, it absorbed energy, right? And that energy caused the electron to become more energetic, and so it was able to move up one level, and then as it returns back to its ground state, it gives off light in the process. Okay, and so these were so when we talk about the electrons, we can say that these really are various energy levels. These electron orbits, aka energy levels, right? Energy levels. That's an important idea for you guys to get there, okay? And as you read this text, this is what he called quanta of energy, okay? This quanta, right? As the energy is absorbed, it's a quanta. As it's released, it's a quanta of energy, okay? And he was actually able to take this a little bit further and actually do some calculations with this, okay? So that's probably how we want to finish our notes here. Bohr derived equations to calculate the amount of energy. Okay, so remember, the goal for this particular chapter was for you to understand Bohr's model. Okay, we want to understand Niels Bohr's model. Okay, which model did he